Okay, so this is the last part of the workshop. Thank you guys for sticking through to the very end. So it's been a really interesting day of talks where we've tried to bring together fields that I think don't typically talk much to each other. So so both Ross and Madalena's talk, we're focusing on trying to understand the psychology of social norms and sort of how people's beliefs are influenced by other people in sort of multi-subject scenarios. And that's really about sort of the science of human cognition and how individuals think. And then we had nice sort of more machine learning orient talks by Natasha and Eugene and Patrick that were about how in multi-agent, specifically reinforcement learning systems, how we can use social coordination between these agents to sort of improve their performance. And then as a final sort of touch, I think Raphael's work and his talk sort of pushes yet sort of a third axis that is how can we use human and AI interaction, so incorporating human preferences into AI learning to come up with new types of social norms that reflect the human preferences, but then can be learned in ways that can maybe scale or that are sort of more robust. So everyone here has been introduced except for Fernando. So let me just take a moment to introduce him. So he did his PhD in Lisbon and sort of physicsy oriented. I actually don't know what the actual degree. I guess it was a computer science degree. Yeah, that's it, right. So computer science. But he then went to the States and worked with Simon Levin, who's a notable sort of broad evolutionary biologist that I think does lots of different interesting sort of evolutionary game theory, population decision-making, collective phenomena type of questions. And now he's back in Europe in a position at the University of Amsterdam, where I think he shares this goal of sort of pushing these ideas both theoretically and sort of how we understand collective decision-making into applied problems, which I think is really interesting. And that's actually specifically why I thought he would be a nice addition to the panel. Okay, so with the stage set, now we can start discussing, right? How do we start this multi-agent trajectory of transmission of ideas and stuff? So because of this sort of disjoint, okay, maybe I shouldn't say it's disjoint, but these different directions from which everyone is coming, I'd like to maybe get each panelist's view on what they think is sort of the main next thing that should be focused on in order to try to integrate these different perspectives. Is it trying to develop better theory but behind the experiments? Is it about increasing the sort of sets of tasks that we sort of test these our science on? Or for instance, is it doing more ethology, just going out and seeing what is out there in more real life scenarios? So is there, who would like to take a stab?
Well, I think the potential collaboration is pretty easy for all of us. I feel like, in the sense, like I was thinking, like especially Raphael mentioned his talk, just like, right, we need some sort of model of human behavior generally. If the goal is to, develop human compatible agents, that requires, training across millions of steps. I mean, in your case, fewer than millions of steps, but like kind of same with like the overcooked work referenced before. My talk on kind of more on the movement dynamic side, and then the talks by Madalena as well, talking about kind of the social norm side, as well as these two as well. That I think that's kind of the exciting area of collaboration is kind of combining the expertise from those in reinforcement learning with those from social psychology, perception action, and kind of exploiting at least our best approximations of human models of behavior to help facilitate at least kind of maybe warm start the design of the training of agents to collaborate with humans. Yeah, that was my initial thought from after all these talks.
I guess maybe we can trade off with Zoom.
Sure. Fernando or Marilena, do you want to?
Yeah, I can say something. I hope the sound is okay in the room.
Yes.
Well, thanks a lot for the invitation. Sorry for not being present here to the talks, but I agree with the previous comment that I think there's a lot of future in the interface of the different disciplines, computer science, social psychology, and just to give some context, one topic that I'm very interested in is social norms in the sense of rules that define what is right or wrong in terms of cooperation with specific agents in systems called indirect reciprocity. So if I cooperate with a certain agent that this agent was not cooperative in the past, should I have a good or a bad reputation? Should my action be assessed as being valuable or not? So there's some theoretical knowledge about these. There's some empirical knowledge. There's some nice experiments in social psychology. And I guess now the interface and combining human agent interactions, for instance, human robot interactions, I think there's a lot of opportunities here for future research on. For example, are people evaluating cooperation with other humans as they are evaluating cooperation with a machine or with an artificial agent? So I completely agree with the previous point that in the interface of the different disciplines, there's the future.
Yeah, I guess I want to bounce off that and something that was said earlier. But like a specific thing that I'm very excited about at the interface is making things that are currently implicit in human behavior models that are learned with machine learning, like more explicit, right? So in like driving land, a lot of the way that we build our human behavior models is we get these like big trajectories and we fit some function that predicts the future evolution of the trajectory from some past chunk of trajectory. I really think one way that we get the amount of data required down and we get good generalization is figuring out ways to build explicit like cognitive models of like human sensing capabilities and things like that into those imitation processes. Like I think that will be really impactful for kind of like imitation learning and human modeling using ML. And this is very much inspired by, well, I only think this, I think that models of humans might work because of Raphael's work, because it worked and I wouldn't have bet that it worked. So so more explicit integration of things that we've learned from like cognitive science and neuroscience into the ML like fitting loop. I think that's gonna be great.
Mm-hmm.
If I can go next,
Okay.
Thanks. I totally agree, and I'm really excited that you guys are building these panels so interdisciplinary, because this is exactly what I'm trying to do as I start a lab and trying to become more interdisciplinary myself and try to get these questions from all these different angles, because like you all said, I also strongly believe that it's at our intersection that we're gonna make a lot more progress at this point. And so I'm excited to start collaborating with machine learners and others to get at these questions from a lot of angles. And what I think is very interesting right now is the ways in which we can contribute our expertise to really start to get a better sense of our processes that we're interested in. For example, we can do in psychology these experiments that are very highly controlled. However, they don't really scale in the way that your agent-based models would. And that's a point of connection that I think it's very meaningful and that I'd be really excited to collaborate on. And then on the other hand, you know, you guys build all these models that are informed by human cognition. But, you know, you need to test them out back into the field and see how kind of they apply and track with what is actually going on in terms of whether or not they actually predict human behaviors in different circumstances in ways that are, you know, responsive to all of the complexities of human interactions and human cultures. And I think that's something that we're going to have a lot more dialogue to be able to figure out. So thanks for this invitation, and I really hope we'll be able to get some collaborations going.
So I think both at this workshop, but also at the posters and the main talks, there were a lot of different, like a lot of similar problems that were like approached in different ways of like, do you use imitation learning, do you use inverse RL, or like how do you try to, yeah, do you want to build a simulation or do you just go from a fixed data set? Like, and I don't have a good way of navigating what is the most appropriate method for which problem. And I think, so for me, it's like personally, I just used what I thought was like the most standard way, and I want to like make it harder until that stops working. Then I think it will be really exciting to go back to all of the ideas that were floating around at this conference to sort of find the most appropriate ones that range from also, yeah, how Ross started with, you know, very psychological ideas of like parameters, like 2 parameters you can fit that like determine the behavior, or yeah, also at the main conference, all of those different ideas that were floating around.
Mm-hmm. Did you want to ask her?
Maybe Eugene apparently has a.
Oh, I was just going to say that I am also very curious when Raphael stuff stops working. And when it does, you should announce it to the world, because I'm so curious when it stops scaling. Maybe it never stops scaling. Just need to know.
Okay, so that's good, because my question gonna be a bit about our strong priors about scale is all you need, or reward is all you need, or Adam Smith is all you need. And we see with the work of Raphael, for instance, how we can step out of our policy and discover even new form of mechanisms. And with Madalena, we saw also why we should maybe do that as a society. So I want to ask everybody here, like, what would be, according to you, maybe the belief of the field that may be the strongest to modulate, maybe to go in that direction? And like in the principles or the way the field of reinforcement learning and decision making has been taking those problems.
Yeah, like which are the social norms that we should be studying?
Typically, but for instance, yesterday we discussed about, for instance, how multi-agent reinforcement learning was kind of a side marginalized part of RL, for instance. But I was surprised as an outsider, because I think like multi-agent dynamics could really bring new principles or so. So I would be curious to have also ideas from people who are more within the field.
I'd be interested to know as well, from someone who's not from an ML background.
Okay. So I'm going to try to avoid saying something that prevents us from recording this. I think if we go back to Natasha's talk for a second, like Natasha provides an argument for why there are benefits to viewing the multi-agent perspective, for deploying something in a world where imitation and social learning is possible and could be an efficient way of learning about the world. It's not the only way. You could do it differently, but maybe it's a faster way to learn about the world than other alternatives. And the other thing I guess I would say is that, like, I think a thing that I believe is that there's more than one way to be intelligent, and there is more than one way to structure interaction between many agents, right? There are many different protocols you could have for interaction between different agents. And we want our agents to operate in human society, which is a particular set of protocols and a particular way of learning about the world. And the multi-agent dynamics kind of shape the type of intelligence that emerges, that you will get a different way of viewing and thinking and operating in the world when you are part of like a long chain of like multi-agent interactions, which we all are. So I think there's like, interesting questions about the ways that multi-agent interactions shape human intelligence, about how to use multi-agent interactions to speed up learning and sharing of information and so on. And I think that there are, for deploying agents that operate in the world with humans, very particular questions we need to answer about how like humans operate. So maybe I went off on a segue there, but yeah.
That's okay.
Yeah, but instead of multi-agent RL being a side project, I feel like it should be the first project, the primary. I mean, just if the goal is to resemble human-like intelligence, I mean, just like clearly from like developmental psychology, like we're born into very social worlds, and our environments are actively constructed by those around us and stuff. And concepts like in Natasha's talk about social learning, for example, where there's clear benefits for observing the actions of others. If you just take it simply as, the search space is so huge that in order for you to develop good policies, in order to develop, adaptive behavior, you kind of do need to rely on the experiences of others around you. That's my take. Yeah.
I just want to push back a tiny little bit on one thing. So we've gotten, if we had started with multi-agent RL, if that had been the first thing we tried to do, we wouldn't have gotten all these like nice algorithms that now underlie the basis of multi-agent RL. Like there's a lot to be taken by like trying to study the single agent learning perspective. A lot we've gotten out of that. So yeah,
that's fair. Yeah.
I think what Josh Tenenbaum said earlier, which was that he was sort of telling everyone at the conference, you're trying to recreate evolution, and it might take a whole planet and billions of years. I think the multi-agent RL is sort of, that's the natural conclusion of that, I think, of just trying to, if the task is constantly set by other agents that are also learning, and you make each other better and better and better, you can just have like an open-ended process that will, if the world is complex enough and if everybody's getting smarter and smarter, it will just end up hopefully producing a very general intelligence. That's the idea. But it's a question of like, is that one you want to interact with or can, or do you have to like affect it a bit more to make it compatible with humans, or guide it a bit more to end up where we want it to end up?
Yeah, I think to the sort of something that Raphael had in there was like this auto curriculum hypothesis, where like intelligent agents push on each other and spur the development of further intelligence. And I guess there's a second component of that, which is really nice, is that like it kind of takes the human out of the loop. Like we don't have to sit there continually designing new complicated problems that we think will make our agents a little better and a little better. And yeah, there's like a really nice aspect that you get out of multi-agent from that too.
Also, like to precise the angle I wanted to have was also in the context of climate change, for instance, or social inequality. How, for instance, we discussed with Michael yesterday, focusing on minimizing regret instead of maximizing value or profit would drastically change over a long term the kind of mechanisms and technologies that we are designing. Like that, I was shocked sometimes at this conference, being an outsider, how certain claim to me sounds like almost ideological at the economical level. And like, for instance, I never seen, for instance, a poster talking about Elon or Ostrom, or more like commons good and stuff like that, for instance.
Fernando, maybe you want to comment, having the background in evolutionary game theory and sort of public good dilemmas?
Yeah, I was listening and thinking on this idea of if multi-agent RL now, one of the goals is to, in a way, replicate evolution, how that might take the whole planet. And I was thinking how, even if we take apart a lot of the complexities that we developed as humans in the long run, complexity related with perception, with computer vision, with movement in the world. So there's a lot of these components that even if we take them apart, we still have fascinating challenges related with solving cooperation dilemmas, solving the exact same problems that Elinor Ostrom attempt to solve or studied on governing the commons. So all of these, I think, multi-agent RL, even if it doesn't aim in the long run to solve all the complexities that we humans evolved to solve at some point, I think could be fantastic if it at least solves the governing the commons type of dilemmas. And I also want to bring the idea that, of course, now we are thinking how humans, how social psychology, how observing human behavior might inspire multi-agent reinforcement learning algorithms and new techniques. But the other way around is also true in the sense that by looking to the complex dynamics that emerge in multi-agent RL, we might also learn about new perspectives of where to look in terms of new experiments to understand human behavior, which I'm not sure if it was entirely related to the question that was posed before, but this is also a direction that I'm quite fascinated about, on how to use the most recent multi-agent RL algorithms or multi-agent systems or even evolutionary game theoretical tools, and how to employ those to steer the direction of social psychology experiments or economics. Also, I deviated a bit on the answer. I'm not sure it was exactly the question.
Okay.
I contribute. It connects also with one of the questions that we prepared about, like how the medium of the communication shape the process of social norm creation, maintenance, and so on. And Madalena, for instance, present well in the case of the sources of the information. For instance, it can play a big role. So that's also maybe a way to change how we're looking at those problem of governance of commands, like the introduction of the signaling and the modality.
As topics of study in
as topic of study more than
sort of like a Marshall McLuhan thing.
Yeah. I mean, it's not because we are from
Do
Canada.
you have maybe some comments on that, Madalena?
Yeah, so that's interesting because you mentioned the source, and that's just one thing that can vary, you know, like that's one of the complexities which we can play with and see what happens. But even if we focus on that one, you know, variable that we want to look at, which is the source, even there, we observe different types of effects depending on different situations. So there's one context in which one source is more effective depending on what your goal is. Say your goal is to change someone's belief. There's a context in which also depending on the belief or depending on other features of the context, like spatial temporal features. So my point is that there's all these complexities that you just have to account for. In experiments, we can control for them, but it just depends on what your question is, I guess. But what we find, for example, in a couple of experiments is that if you're trying to change a political belief, for instance, I think I mentioned this in my talk, the best source, the most effective source would be a non-denominated large group of other people. And we would have thought that the best source would be someone who you identify with. So for example, for Republican participants, we thought they would be more convinced by a group of Republican people who want to change their mind, and that wasn't the case. So in this one instance, we were kind of shocked by this result. But also we have to keep in mind that there's other features of the context that shape these results, and they shape them according to the socio-political context under which we're asking these questions and all of that. So I think there's a huge level of complexity that is at play here, and it just I think there's a lot to dig before we can have some clear answers on, even a simple question as what the source effects might be on social influence, for instance.
Yeah, I think the point that Madalena just raised there is like very, very interesting, and kind of goes back to the point you were making about reward maximization, because I'm being speculative here, but I'm not certain that like a rational reward maximizing agent gets the place where it like updates its belief less on things that are from agents that are like it than like a non-denominational set. Like I think that's like a very particular thing. I don't know that you get that in a reward maximization framework of a single agent. It's like seems weird to me if that was true.
Yeah, well, it's connect, for instance, with active learning or active inference, where you have a reward not for just like value, but also for epistemic update of your belief.
Well, the reward people would say that like that's just emergent from trying to maximize your reward.
Yeah, okay, so you merge the reward. I think like in a way also maybe it's a semantic thing that could become ideological if you take the term reward straightforwardly. Yeah.
So I think, if I may, I think my whole kind of talk kind of hinged on this idea that there's cognitive processes that we observe that kind of go a little bit against what we would expect a rational agent to do. So most of my experiments show that, look, the rational agent model would predict this to happen. And we observe in these experiments that human behavior, human cognitive functions kind of don't always follow that expectation. So a lot of social and cognitive psychology right now are trying to understand what causes these differences between, just taking a step further from the rational model and trying to understand what are the other features that explain all of these behaviors and decisions that the rational agent model can't explain. And yeah, I think it's in our view, at least from this point of social psychology at the moment, there's these two forces, and I guess you can call them the reward maximizing function, but the two forces that pull people's behaviors in this new view are that people are trying to be rational and they have this accuracy goal, but then an equally or maybe even stronger motivational force is this identity-based social cognition, which pulls people in this direction of, well, rationally I should do this, but because I'm motivated to align with my group, I will engage in all these other cognitive functions and cognitive processes that will lead the outcome to be a little bit further from what the rational model would say. So I think having both of these views in taking them into account and understanding kind of how both of them could be what people are trying to maximize is something that we could, I think, start a conversation about, because it's a lot of what the discussion in a lot of the social sciences is right now.
I was wondering if this thought about, how humans don't exhibit this rational type of behavior. I mean, well, there's, heuristic following and stuff, but is it possible when we define these reward functions? So if you were to take a reward function is a scalar representation of a task, and that, when we're, just in general, like we're not engaged in any given task at any given time, in the sense that, you know, there's at least, okay, you might be engaged in a task, but right, there's like task competition, I suppose, you know, things that are drawing your attention away. I don't know, I'm trying to think of like Paul Zizek or something, like the affordance competition idea that I'm wondering if you were, if, I don't know, if you guys had a specific thought in the sense of like, you know, you maybe if it's related to like auxiliary reward functions, for example, but almost like, yeah, just like task competition.
Maybe something to just to be clear that
Yeah.
like rational is in some sense a technical term tied to a particular objective. Rational means best with respect to a given objective. And so the question is, well, what are the objectives? And which ones should we build into the agents, and how can we infer human objectives, which is a traditionally quite hard problem. You can even do algorithms like inverse reinforcement learning on human behavior to infer what reward functions are, but that's still going to depend on the model that you choose for the agent. So
yes, I think it's an excellent point. And actually, even within a context where there's homogeneity in the reward functions of agents, and even if within this framework of reward maximization, only accounting for asymmetries in exposure to information, for example, and biases in how individuals might exacerbate or disregard that information, that might provide some explanations, or that might provide some justifications for why you observe seemingly irrational behaviors around us. And there might be situations where this type of perception biases might be maladaptive. There's situations where these perception biases might actually lead to improvements. So within the framework of evolutionary game theory, something that we've been working on understanding in the context of cooperation dilemmas and collective action dilemmas, how these biases and how exposure to different sources of information might lead to benefits or just collective failures in the long run, which is something that perhaps also within multi-agent reinforcement learning. So I don't know of any works. Maybe you know in the room about works on how these information asymmetries or biases in interpreting information impact multi-agent reinforcement learning dynamics. But I think that might perhaps be an interesting point to discuss at some point.
yeah, yeah, we can take some questions from the audience if they still have. Yeah, you guys can share.
Yeah, thanks for all those thought-provoking discussions. I guess one thing that just built off of what we have been talking about, you guys have been talking about, is that in some cases, people do not behave as they believe. And I think people believe in that, right? It's very obvious that I think Amazon is evil, but I keep buying things from them. And if you ask me, that doesn't make sense. I was like, I know, but I don't care, right? So it's a very common discrepancy between what people's reasoning lead to and what their action lead to. And then what that challenge in both, I think, AI community and behavioral science community is that we build model off of people's action, right? Even the rational, like most of the computational literature in for example, IRL or inverse planning is designing environments, and we infer based upon the agents or human subjects' behavior, right? So in that context, it's successful because we're judging based upon their actions. And there's another line of work like, excuse me, I pronounced the name incorrectly, Madalena, is that right? Madalena's work is not really modeling based, at least not as the one she presented. And that's in a way has its advantage in that it's more about people's mental reasoning, and which is more language-based. So I think I'm curious about your thoughts on what do you think of this discrepancy, and how can we merge this, right? Of course, we want to model everything if possible, but it seems there's a difficulty in capturing some of the richness of human language semantics and human belief as it's being described by the natural language, instead of some more quantifiable way as modelers typically study it. Yeah, I don't know if I made myself clear on that.
Yeah, thank you for that question. I think a lot about that, and it's a really great question, and it's really on everyone's mind, I think, at the moment. Why is there this big disconnect between people's beliefs and their behaviors, their actions? That's something that there's so many theoretical models in social psychology, like old school, like from 100 years ago, where they're trying to say, like, wait, like, we kind of think beliefs should predict behaviors, and they do sometimes. But there's all of these interactions with a lot of different forces that will produce all of these conflicting findings, and you will find that there's these instances in which beliefs do predict behaviors. So I actually picked up this line of work a few years ago, because after giving my talk on belief change, almost 100% of the time that question is, does that translate into behavioral change? So I had to figure it out. So the literature, at least in psychology, is very conflicting. So on the one hand, there's situations in which beliefs predict behaviors very strongly. So for example, at least correlationally, religious beliefs predict learning success. Religious beliefs predict crime rates very strongly. Then beliefs about intelligence predict learning success, and beliefs about health behaviors predict those behaviors. So there's particular instances under which this disconnect isn't there. But then there's instances in which, for example, your belief about an outgroup member does not predict your interactions with that outgroup member, and doesn't predict your behaviors when you're interacting with them. So we're trying to disentangle right now, what are these situations? Do beliefs interact with social norms, and do social norms trump beliefs when they go head in head? Or are there other features that interact with this, just creating this super complex model? So that's what we're doing right now, trying to understand this in the context of climate action. So I mentioned briefly this study we've launched already on understanding collective climate action. So we're deploying a massive randomized control trial in over 80 countries, and trying to understand, first of all, what are the psychological drivers of climate action? So what are these interventions that we, as policymakers, for example, can really use and be effective in getting people to individually change their behaviors, change their voting behaviors at the collective level. So support climate policy, which actually has pretty low support because it would raise taxes. So it's like a duality, like you would gain something at the collective level, but you lose something at the individual level. And so in this kind of context, we're trying to bridge the gap, because we will have a huge data set, and we'll have all these different psychological mechanisms by which we'll be able to see when beliefs predict behaviors and when they don't. So this is something I'm looking forward to in this data set that will be collected by the end of this year. But other than this, there's experiments that we're doing, trying to understand what are these situations under which we can bridge this belief behavior gap. There's also a huge intention action gap. So people, let alone belief, but intention to behave in a certain way. Like my intention can be to vote, and on the day of, I might not actually go through with it. So there's another huge field trying to bridge the intention action gap. And there are some pretty good interventions there that have been shown pretty promising at bridging that gap. So I can go into that if you're interested, but that's just like at the top of my mind at this moment.
Thanks, Madalena. Eugene just had to leave because he has to catch a flight like right now, and he had told me beforehand. So thanks, Eugene. Yeah, I don't know. There's just, I mean, we should probably wrap up soon, but I think we've covered quite a bit. Yeah, I think this workshop has tried to sort of cover both the AI alignment problem to some extent, but I think it's also revealed that there's sort of there's a complex way in which like the human value alignment problem is also going to play a role in that. And let's hope that, you know, we can design AI that contributes positively to that. We are running a little behind schedule, so why don't we end it here and just thank all the speakers for their great talks and contributions. They should be available online in the next couple of days. So yeah, thanks again, everyone.
Thank you.
Thank you, everyone.
Did you just close it?